resolving force vectors, section 4.4 in your notes. And the worksheet, you'll just do number 1, 2, and 4. Excuse me. For this assignment 1, 2, and 4, I might try to think. I'll probably have you do the other assignments, the other problems after I go over these one day. Or I'll check. Or either that or I'll just skip the other ones. But we'll see how time goes. Because it takes a little bit of practice. This is very similar to the very first thing we did when we opened this semester for Zoom. It's like I told you here's a little intro lesson with all these changing having a line, an angle, and then breaking it up into an X and a Y component. So it's really very similar to that. And you'll see also, it'll remind you of something from last semester with the vectors we did with velocity. But the good news is, the bad news is, I'll say, this is probably one of the tougher things in the chapter. But the good news is, it's not going to be very prevalent. You'll see it'll pop up in more times as we come along. But you'll get better at it. But it's not going to be like we're going to sit there and dwell on this for every single day. But you are going to see it come into play. You'll see a few more times in this chapter. Okay, so resolving force vectors. Now, what I wrote here in the beginning of 4.4, it says, imagine that this sphere is suspended in outer space, meaning there's no gravity, no air, nothing around it. And we're still going to use north, south, west, and east, even though there really wouldn't be a north, south, west, and east. But we're still going to use that just to help us to get the direction better. Now, we could, and this is what they'll do maybe in college as well. I'm just like, in college they'll do something more like this. They'll just say, here's your negative x, your positive x. Here's your positive y, your negative y. Instead of saying north, south, west, and east, they're going to say it'll be 10 newtons in the positive y direction, or at 10 degrees below the positive y direction. Things like that, or negative y. I don't want to do that. So we'll just say north, south, west, east. It'll be easier. And plus, this, as I said, it's a fairly minor thing that we're doing. But you should know about that. I mean, you would know the number line, negative x, negative y, positive y. And you can do the problem the same way. Okay, so I kind of did this for you on the first day, but now it's on a video, so it'll explain a little bit better. So here's a sphere. Actually, I've got one here, too. I can show you. Like I showed you, a little one like that. All right? And it says, it has a force of 25 newtons pushing it and 15 newtons pulling it. Now, here's the thing. Pushing or pulling, it doesn't really, they both can kind of do the same thing, and I'll show you what I mean for your answer. So it's pushing 25 south. So south is down that way. So you can, for now, don't draw it yet, but let's just say 25 newtons pushing it south. And it also has 15 newtons pushing it west. And that would mean like this, pulling it west. Pulling, you more normally think of it that way. All right, so 15, pulling it west. Okay, now here's the thing though, gotta be careful with this drawing. This would not be correct. Now, you would think, if I'm pushing it this way and pulling it that way, which way is it going to go? And you can probably figure that out, can't you? Is it going to go this way? No. Is it going to go that way? No. For sure it's not going to go that way or that way. If you're pushing down and pulling at the same time, it's going to go this way, diagonal. Now, your arrows don't really show that. You know why? Because I didn't really, well, no, they do show that. I can't believe that. They do show that. Because if I take this arrow, the end of this arrow, and I draw the other arrow, then I'll get this diagonal right there. That would actually give me my answer. But what I was going to tell you, this might make it easier. If I say you're pushing 25 down, it's okay for the force to be down here. In fact, it can be right here too. It's all right to do that. This will give you the same number that will give you. All right. Now, the angle might be stated a little bit differently here, like south of west, but that's okay. So I'm going to just move it over to there. If you want to do it up there, you can. You can do that as well. But I'll just do it down that way. All right. Now, So I'm going to label this up here again. So 15 newtons and 25. I mean, that should be short and that should be longer, really. I guess I'll make it a little bit longer. Yeah, just to show you. Sometimes your drawing might not be, it won't be perfect. Now, I'll tell you about this, and I mentioned it before. If you're like in, one day engineering and all of that, if you want to do just right, if you have graph paper, especially with really the smaller boxes, where there's like 10 boxes, there's like a big square that has like 10 by 10 boxes, so 100. 10 boxes, another big dark line, 10 boxes, and so forth. You could actually go 15 squares this way on your graph paper, and then 25 that way on your graph paper. And if you measure this, well, I'm about to say if you measure it, it will give you the correct distance. But actually, in what unit? You'd have to measure it in the whatever the graph is. It's probably millimeters. But if you had the perfect paper and drew it, you'd have. But at least you'll have a perfect drawing for that. 15 boxes, 25 boxes, and that will give you the right perspective. But it's okay. Just say you drew it like this, okay? Now, that wouldn't be correct because this one is shorter and that one's longer, but you'll still mathematically get the right thing. It's just sometimes you might say, wow, it says my answer is, 200 and whatever, and it's smaller than this other line I drew. So the picture might look weird, but I don't care about that so much. If I ever want to grade the diagram, I'll let you know. If I'm going to say, hey, if your diagram, or you can sometimes there's some problems we'll do, and your answer will be like the wheel might rotate, but in the opposite direction that I indicated on my diagram. Because sometimes you'll pick a direction. That's not till later in the semester. All right, here we go. All right, so what is the resultant force, R? Fr. Now, I like to call this one, we can call that F, Y and Fx. So I'm still going to use X and Y, but not the X and Y axis. So we'll just say Fx, Fy, and Fr. Okay. And then we'll think about north, south, east, west when we do our final. So first, how am I going to find it? You can use Pythagorean theorem if you want, or you can take the shortcuts around it by using tangent. So in fact, let me just go on and do that because I do want the angle. I'll do it the tangent way first. Let's find this angle right here. We know that tangent of that angle is equal to opposite over adjacent. Okay, so 25 over 15. 25 newtons over 15 newtons. So that means that theta will equal tangent -1, inverse tangent of 25 over 15, which is 25. Sorry, if you want to see that, 25 divided by 15 equals, and then don't push tangent, but push the second function and then tangent. And that way you get the tan -1 that's above it. So 59, sorry about it, 59 degrees. Or it's just 59 degrees, no O's on it. Okay, now it's 59 degrees. And see, when I look at that picture, it's easy for me to see. This is west, but I'm going to go south of west. So 59 degrees south of west. That's the way they do it. Now, a lot of textbooks might say instead, they won't do the north-south. They'll just say 59 degrees below the negative x-axis. So that's the way that they might, in college, they probably will expect it that way. Now, you will see north, south, west, and east when you deal with velocity, direction, like we did in the last chapter, but not with forces. But I wanted to do that just to make it easier. I just think it's easier to remember north, south, west, east. But it's 59 below the negative x-axis. I don't care. I really care about this, and then I do want the direction. I'll put that. Now, let's find out what is the resultant. Well, I don't know. Now that I've done that, should I go in and find it with both? Well, I'll do it both ways. Okay, if I want to use like sine of this angle is opposite over hypotenuse. Sine of theta will be 25 over FR. So, sine of the angle is 59 degrees equals 25 over FR. So what is sine of 59? It is 0.857. So 0.857 times FR, you'll take, well, I'll write it all down. 0.857 is 25 over FR. So 0.857. I'm putting every little math step. And you don't have to do this if you're better with your algebra and all. In fact, I left off, in the very first step, I like to write the unit, newtons. And then at the end, I don't want to put it along the way because I might think it's a number and mess up something. But 0.857, all right, so that means I divide both by 0.857. And FR, the resultant force, equals 29.2. Nope, sorry about that, 29. I'm thinking about my sig figs, and I always tell people in my chem classes, just round it to 3 if you're in doubt. But it's 29. So 15, 25, 29. See, those numbers are reasonably kind of close together and stuff, so that sounds good. And the hypotenuse is always bigger than the other two. So you know that if that's larger, that also tells you did it right. Well, I consider this right here to be a shortcut to doing the math. But of course, you might rather just do it this way and say, okay, FR squared equals FX squared plus FY squared. So FR, let's get FQ, doesn't it? FR equals, what is FX? 25 squared plus 15 squared. Maybe that's easier for you. What is that, 625? And what is 15 times 15 is 225. That might be easier for some of you, 850. But I'll tell you, then that's going to be FR squared is 850. So take the square root of FR squared, square root of 850, and the square root of 850 is 29. So, you know, you might feel comfortable with that, and that's okay. You might want to do that to find the resultant. And then, yeah, you might like that better. I shouldn't have jumped into this so quick. So do this first, and then you can find the tangent with the angle. But I will tell you that later on, as we get in later chapters, we do this more and more. This is actually going to be a shortcut. In a lot of cases, it's easier to do this to find your unknown instead of having to go through the Pythagorean. But in this problem, it looks like that was shorter. So, oh well. I don't know. You'll see what I mean later on. Okay, so, but if anything, they're about equal in how long it takes. I think the math is actually, it might not seem like it, but the math to do sine is easier because there you got to square two numbers, you got to add them, and then you got to remember to take the square root, and you can forget that. But of course, on sine, it's more of algebra left, you know. So you can just choose as you want. Okay. Now, here's another one. I might actually add on to one of these problems to make it a little bit more like the one on a worksheet. On the worksheet, I'm having you do number 1, 2, and number 5. B says, sphere B, we'll just name that whatever. This could be B, I guess. Has a force of 58 newtons pushing it from 35 degrees north of west. Okay, it's coming from 35 degrees north of west. Now, let me move this over. My hand is the eraser. North, south, west, east. If you're coming from north of west, so you're coming from like that way, that'll be like northwest. So you're coming that way. It says from, oh, hold on a minute, 25 degrees, 35 degrees north of west. Yeah, okay, so kind of strange, but so that will be 35 degrees right there. So it would look like that. Now, I'll tell you that on a lot of like quiz or test things you see me, they're going to be giving you, I'm going to probably give you the diagram. And in fact, for this chapter and for the ones that follow as well, you'll see it. So you won't have to worry. But that's kind of strange. But from north to west, it's giving 35, it's pushing with 58 newtons. Now it says, okay, resolve this into its north and west component. Oh, this is not too hard. All they want you to do here is just find out, okay, if this angle is 35 degrees, make sure you know that's degrees, not newtons, then what would be these two forces? I'll still call it Fx and Fy. Now, they're actually, Fx is, okay, it says resolve it to its north and west component. So Fx will be the west component, and that will be the northern component. So this is where my north and west might be a little bit, mixing you up a little bit. Just here's your force, find the x and the y of that force. Okay, so this is easy, I hope. Sine and cosine. So remember, sine of 35 degrees will equal Fy, opposite over 58. And so we'll find that one. So just put sine 35. Sine is 0.573. I'll write it down. And then times 58 is 33.3 equals Fy. So Fy is 33.3. And then I'll use cosine to find the other one for Fx. I guess I drew my picture kind of small, didn't I, there? I could have made it larger. I wasn't thinking, but okay. I might redraw it in a moment. Yeah, maybe I will. Okay, let's see. So cosine of 35 will be Fx over 58. Sorry. All right, so cosine 35 is 0.819 equals Fx over 58. So multiply 0.819 times 58, 47.5 equals Fx. So 33.3 is Fy and 47.5 is Fx. I'm sorry I made it so small here, but because I'm going to do more with it on the next problem. So we'll do this. So that should have been 35 degrees. And then here's the sphere. All right, and then we said that Fx, Fy, and 58 newtons is this one. And we just found Fx and Fy. In fact, I'll write it down. We said Fx is 47.5. And Fy is 33.3. Actually, hold on, there's something more to do with this. Okay, Fy, what direction? It's actually going down because you're pushing this way. So Fy should be negative. When you see the picture, it makes a little bit more sense. That should be a negative. You won't know till you look at the picture. And Fx is pushing that way, so Fx is going in the positive direction. So it is positive. I don't normally write positive for positive, but you might want to, because I'm going to show you why in a minute. We're going to do something with that. All right, so there's my Fx and Fy, negative 33 newtons and positive 47.5. Now, letter C says this. Okay, watch. It says, if a force of 59 west is also added to sphere B, what would be the net force on it? Okay, so if we add a force of 59, so this is part C. I'm going to add a 59 Newton force, 59 moving west, or pulling, what does it say? It just says west. It can be push or pull. So I'll just put it like this. Watch. I'm going to put it that way, west. 59 newtons west. I guess it will be a little bit longer. It'll be almost the same as that length it should be if I did it right to scale again. Now, so where is the little sphere going to end up? Here it is. So it's like this. One is pushing it that way, and one is pushing it that way. Which way will it go? You might remember this, but this is where you use the little chart. Okay? So we go to the chart, and I can say force. Okay. We didn't really have a name. Sometimes we call it like FA, FB, or whatever on a picture. Or in this case, I can just call it the force 58. I'll call it that. And then we have the force 59. And then we're going to have the net force. Is this going to work? Let me think about my chart. Sometimes I make my chart different on that, but we'll see. Now, I'm going to put here the Fx and here the Fy. Okay, so watch what I'm going to do. First, let's go to the 58 Newton force. What is the X and what is the Y? Okay, so the X is actually positive 47.5 newtons. So So it is going that way. So if you wanted to, you could imagine that this thing has like the sphere has 3 forces on it, and it would still be true. It's like saying I got this force on it, I've got this force on it, and that should be smaller, right? And then I've got also this force on it. 30, that will be 33, that will be 47.5, and that will be 59. This will give you the same result that you get from here. But in the chart, you can do it this way. It's probably better just to label them in here. So the 58 Newton force, or if we want to call it FA or whatever, negative 33, okay, we put, is for your FY. Okay, I didn't mention that. Negative 33. You know, I don't need to have my 0.3. I just realized that. Again, I keep going to my chemistry sig fig stuff. So I guess that could be 48, actually. Yeah, I'll make it 48. If it was 47.5, then I could make it 48. I can't remember. If it were 47.4 or something, then I don't know if I would do that. But oh well. Okay, here we go. Like 49. All right, but 48, there we are. Negative 33. So positive 48 for fx. Okay. Oh, yeah, 48, I said. Positive 48 and negative 33 for that one. Now, for the other force, call this one Fy. And you just write the name on there. Oh, no, I'm sorry. No. F59. I didn't want to call it Fy because I have a bunch of Fy's. Okay. F59 and F58. Well, F59 is only has an X, Fx, and it's going to be 59. And is it positive or negative? It's going that way, so it is negative, actually. So actually, we should put a minus there. Negative 59. What is the Fy for F59? There is none. Fy would mean how much is going north or south, up or down, and there's none. It's 0. Now I'm going to add these together. 48 minus 59 gives you negative 11. So what that tells us is that, you know, it's like a tug of war. You got 48 pushing you this way, 48, and 59 that way. Of course, he's going to win the tug of war. 59 is going to be going that way, negative. You're going to be going negative, but only 11 will be your force. And then your down force, negative 33, is still going to work. So overall, it's going to be heading like that way. Okay. All right. In fact, well, that's what we got to do next. So you want to calculate the net force and also get the angle. So when you get to this part, you put, now you could even have 3 forces, X, Y, and whatever, and then you get your net. But when you get to your net, make a new triangle like this, okay? So let's just go here for a minute and say, all right, negative 11. So I'm going to draw one line, negative 11, like that. Like on the sphere, or whatever you want to say. And then negative 33. Now remember, the end of this one needs to be okay. This is what do you call that? The head, the tail. Well, you get to do it this way. 33 is going to be a lot longer, like maybe down to here or something. Negative 33. So in other words, what we're doing is negative 11 and negative 33 for your y. Then from that, we don't really need these other lines here. Then we'll get our resultant right here and get the, let me see. Well, let me use another color. Okay, and then I'll get the angle right there. It looks like it's going to be south to west again. That was just kind of coincidence. Okay, so I'll use Pythagorean because that seemed to be better last time. What is the resultant force? Fr squared is equal to negative 11 squared plus negative 33 squared. Now, they're all in newtons, if you want to put a little n down there. On the first step, maybe. 11 times 11 is 121, right? Okay. So 121 will be a positive here. And 33 squared is 1089. Add them up, and you get 1210. Then don't forget, you got to get your, sorry about that, I left off the squared. You got to get your square root of this side and square root of that side. Square root of 1210 is 34.7, or 35. Forgot about that, my sig fig stuff. 35 newtons would be Fr. And if you look again, 35, 33, it's bigger than these two, and it's not too crazy. Like if you said like 3,000 or something, 33, 11, 3, you know you did your math wrong. Like 1210 would remind you, hey, it didn't jump that high. It's going to be somewhere in the vicinity of the others, okay? Now, to get the angle, I will use tangent -1, 33 over 11. So, tangent of -1, well, tangent of theta equals -33 over -11. And you can just leave off when it's two negatives like that. So, theta equals tangent -1 of 33 over 11. I hope you can read that messiness there. Okay, 33 divided by 11 is 3, and then shift tangent of that is 72 degrees. And again, it just ended up being south of west. Well, I guess it wasn't. Last time it was north, was it? I think so. So, 35 newtons at 72 degrees south of west. So, on the paper, you'll try and do number 1, 2, and then number 4 has you kind of combining those. And then we might go over it in class one day and then another day, and we'll before we do the other part. I'll see you.